And we're off. All right. So again, I apologize that you have to operate off of these couple of TVs for now. I will do the best I can to expedite getting this room fixed for the time being until we're able to move across the hall. But I guess one thing I'd say is a lot of you are on, have laptops. I sent an email out this morning with the Zoom link. If you wanted to, you could join Zoom, which I share my screen on. Just maybe don't turn the audio on. Keep your computer muted. That way you'll see my screen probably better than you can see up here. So that's a current, what's called hybrid approach. So also sorry for the late email. I just got access to our class this morning. So yeah, we're firing on all cylinders here. Okay, so this is CSC200 coding 1. Everybody in the right place? All right, we do have a little bit of a weird population in here because we are also serving the 200 class from Concordia, Ann Arbor. So we have some online students, which means that if there is ever a situation when you are sick or something like that and do need to attend class on Zoom, that will always be available. My preference is that you always come in person. All right, so try not to use the attend via Zoom as a crutch, but it's available if you're coughing, sneezing all over the place, and it's either don't show up to class or go on Zoom, go on Zoom. I also record all my lectures, so they will all be up on YouTube. I'll put a link up to the playlist, so you'll have everything. I'll get all that hopefully done today and open up the Blackboard class. Like I said, I think I got access to it like around 2 or 3 in the morning is when it looked like I got the notification email that they associated me with the class. But first week woes, I suppose. All right. Well, so let me introduce myself. So I'm Mike Littman, the chair of the computer science department. I teach a lot of our coding classes. So you have the pleasure of having me teaching you how to program. How many of you have coded before? Okay, roughly half of you. All right. I make the assumption that you have never seen programming before. Okay, when you come into this class. I also tend to go into more detail than you maybe would have had if for some of you had coding maybe in high school or something like that. I am of the opinion that programming is a skill set. The language does not matter. I've been teaching this for 25 years. I've been coding since I was 9. So learning programming languages is actually a pretty easy thing once you understand you have the computer programming skill set. And we're going to talk about that quite a bit today. So you'll actually find that we're going to spend a couple of weeks talking about a lot of background stuff before we even write our first line of code. I promise you that will make you a better programmer, okay? Because we're not just teaching you how to write an if statement or create a variable or something like that. You want to understand the why, what's happening under the hood, and then how to do it, because that is then going to allow you to solve that last 20% of problems that people who go and do coding boot camps can't solve. All right, and that'll make more sense as we get into it. All right, so my email address, and this will be up on Blackboard as well. So best way to reach me is either via email or text. Either one of those will work. Also, we have a Slack channel for the department, which I encourage everybody to get on. I will include the tutorial video on how to join our Slack channel. But if you are familiar with Slack, you want to go to cuwcs.slack.com and you can create your account, but you need to log in with your Concordia email. Otherwise, it won't let you into the account. But I have a 3-minute tutorial video that I'll put up on Blackboard that it takes you step by step on getting onto our Slack channel. So you can also message me on Slack. There will be a course set up for CSC200 that you'll be able to join. So I'll, sometimes people ask questions about homework assignments, things like that in that channel. Feel free for anybody to answer those questions, or I'll answer in there as well. And we'll talk kind of how grades work here in a second. But Slack's a good tool for that. And if you get it installed it runs on all your laptops, Mac and PC and Linux, and it runs on all your phones, Android and iOS, and it comes in like a push notification. So it's basically the same as texting. All right. We also use Slack to put up opportunities for internships and that kind of stuff. So another good tool to get involved with in the department. Okay, so that is getting a hold of me. In general, I would say that if you email me or text me or Slack me and I don't reply within a couple of hours during, let's call it like daylight hours, like not asleep, go ahead and send it again. I promise you're not bugging me. I get like 500 emails a day. Bump it to the top of my inbox and I'll make sure that you get my attention. So I won't be mad if you're nagging me. All right. Grades in the class. Don't freak out yet. All right. So 70% of your grade in this class will be exams. We have 2 exams in here. We have a midterm and a final. 30% will be homework assignments, which will be primarily programming assignments, but there'll be some papers and things like that a little bit early on. And I'll talk about the nature of homework as we kind of get into it. But I mentioned a few minutes ago that my mindset on computer programming is a little bit different than I think traditional mindset is. My mindset on grades is also a little bit different. I view really any subject, but specifically computer programming as kind of being like a sport. All right, so how many of you play some kind of sport? Soccer, baseball, basketball, tennis, okay? So let's just use an example of like basketball. Okay, since everybody in here has heard of Michael Jordan, we'll just use him as an example, right? Everybody's heard of Michael Jordan. All right. So you can go to Michael Jordan's basketball boot camp and academically learn all these basketball skills. And if you're in there for 10 hours a day for 2 weeks, are you ready for the NBA? No. You might have a lot of academic knowledge. You might know techniques for shooting a jump shot, something like that. Okay. But until you've put in thousands and thousands of reps, you're not going to progress to the next level and get better and better. So for those of you who maybe are good at sports, think back to when you first started that sport and you probably were not very good, right? You've put in a lot of reps, a lot of effort. You've messed up at practice, things like that. I view homework like practice for the big game. All right. I tend to grade homework very easily. All right. When I give you programming assignments, I want you to struggle with them. Sometimes you're going to spend 4 or 5 hours on your homework assignments. And then we come to class and you're going to see me solve it in 2 minutes. Okay. I always write solutions to the homework live in class. I don't just bring up the solution. You'll see my thought process as I'm going through it and I'll talk through it. All right. But I promise you that 4 or 5 hours you spent is going to pay dividends, because that's like you out there shooting free throws for 4 or 5 hours until you finally get better. Although Shaq never really kind of improved, but in general, that's kind of the idea. All right. Similarly, I encourage you to get into study groups for the homework assignments, collaborate, work together. I don't care. I'm not going to sit there looking for people cheating on homework assignments. I'm going to find out on the exams, right? Whether you're learning the stuff. Ultimately, the goal in school is for you to learn information, you to get information, process it, learn it, and then prove to your teachers that you've actually learned the material. My job by the end of the semester is to give you a grade based on how well you've mastered the material. Okay? With that in mind, I give 2 exams. I give a midterm right around week 8, and I give a final exam during final exams week. My policy is if you do better on the final exam than you did on the midterm, I will replace whatever grade you got on the midterm exam with the grade you got on the final. So if you come into the midterm and you haven't quite learned this stuff yet, or you've been slacking off, not really doing your homework yourself, relying on your study partners too much or your best friend too much, whatever it is, you'll get your wake-up call when you get your 5% on the midterm, and that is effectively 35% of your grade on paper. All right. You can undo that grade. All right. That's your wake up call. come back in, work harder the last 8 weeks, put those reps in yourself, or make sure you are converting the help you're getting from your classmates into knowledge that you're then practicing, okay? Because you're going to get probably close to full credit on all the homework. That's not the point, right? You know, the point is I want you putting in those reps. I want you to be practicing, you know. So here in class, I'm showing you the fundamentals. Then you go home and you practice on your own so that when we get to the big game, you're ready to perform, all right? But you're really being judged in the final big game at the final exam because you can fix any bad grade that you got on the midterm. Make sense? Pretty fair policy. Got every chance in the world to show me that you understand the stuff. Okay. So that's the scoop. My exams are all short answer essay programming, no multiple choice, no true false. So no trick questions or anything like that. My exams are competency based. So I'll ask you a question, you're going to give me your answer, and you know, I'll give you a grade based on how competent your answer was. Keep in mind, again, I've been doing this for a long time, longer than most of you have been alive. So I know the whole strew when you dance around a subject but never actually answer the question. You know, I just give you a 0 and move on, right? Unless you write something funny. I do like funny things on exams, and sometimes that's worth a point. All right, so we've had some good ones before too. But in any case, I'm pretty laid back, pretty easy grader, but I, from a homework perspective, but I hold you accountable on the exams. So that's what you're really preparing for in this class, is to perform well on the exams. And having said that, programming is hard, okay? And we're going to talk about that today. I'm going to try to put it into some context for you. For those of you who've had some programming before, how many of you thought it was pretty difficult? Probably several of you. It's kind of a complexy thing, right? All right, if you haven't had programming before, maybe you're a little bit intimidated, like, okay, this sounds like it's a hard thing. I see in the movies, the random codes we see on the screen and stuff, that's freaky deaky, whatever. You know, then you used to watch the Matrix movies and somehow the guy's reading the 0s and 1s on the screen and that's supposed to be meaningful. You know, it fakes us out, right? I promise, programming is easier than the problem solving you do on a daily basis. The real problem here is all of you have spent 17, 18, 19, 20 plus years of your life interacting with other human beings. You're good at talking to other human beings. You're good at problem solving with other human beings. Most of you have not spent very much time or any time talking to a computer, telling a computer what to do. You don't have that skill set. Human beings are smart. We can fill in the gaps. Right? If you're having a party at your house, you can give a human being directions. Say, yeah, go down. It's like the second or third light. There's going to be a gas station on the left. You turn left there, and I'm like the third driveway on the right. You're going to see this big dead tree in the front or something, you know, some vague instructions, right? And human beings can fill in the gaps, right? We'll probably find the place. We might drive by 2 or 3 times, but finally kind of arrive. Computers can't do that. Let's say yet. AI is getting pretty sick. Okay, but generally speaking, right now, computers can't do that. So what you need to do is you need to become a good programmer. You need to change your mindset, to drop it down to the point where you now solve problems by breaking them into little tiny steps, because you have to fully articulate the solution to a problem to the computer. All right, that makes some sense? That's the difficult part of programming, not the syntax. How many of you speak a second language or a third language or a fourth language? Okay. So let's assume the second language is Spanish. Use that as an example. If you speak English and you speak Spanish fluently, when you're talking to your Spanish speaking friends in Spanish, your mindset is identical to when you're talking to your English speaking friends in English. You're just using a different syntax. Make sense? You're still dealing with a human being. Just as if you're speaking C++ to the computer, or you're speaking Java to the computer, or you're speaking Python to the computer, or insert programming language you've heard of, it's the same thing. You're still talking to a computer. Every single programming language solves the same problem. The syntax just might be a little bit different, although we're going to learn that it's not as different as you might believe if you haven't seen multiple languages before. All right. But that's the context of the problem we're really trying to solve. We're learning how to tell a computer what to do. And we're going to leverage a programming language to do that. And because my philosophy is that the language does not matter, computer programming is the skill set, we're going to change languages up on you often. This entire first class, maybe until the very end, we might start switching to the language we use in the second course, will be in a language called C++. How many of you have ever heard of or coded in C++? Who's coded in C++? Half a person? It's full person-ish. Okay. So C++ is not the friendliest language in the world, which is exactly why I chose it. And let me give you some context for that. C++ is a pretty old language. And actually, for most of the first class, at least through midterm, we're really going to be programming in C. C++ is the object-oriented version of C. I just noticed that somebody has a Ninja Turtle shirt on, so I need to pause for a second. What's the best turtle? Only one correct answer.
It has to be on your. It's on your. Yeah, Donatello on your.
It's Donatello. Was that what you were going to say?
I was gonna probably say Michelangelo.
He's the worst turtle.
That would be rough.
Well, he's the worst turtle because, first of all, my name's Mike. So you imagine that most people make that guess initially because, oh, we have the, same, Mikey, right? We have the same name. Because that's what they call him in the newer cartoons and stuff, is Mikey. No, he's an idiot, right? I mean, he should have a pretty good weight loss video because he stays pretty skinny given the amount of pizza he eats. But Donatello's the smart, nerdy one. There's a second best, it's Leonardo. Because he's got, leadership skills, he kind of holds the band together. Raphael's just a meathead, so he's a waste of time, right? But by the way, Ninja Turtle stuff does make it onto the exams. And I'm not kidding. So you want to brush up on bandana colors, weapons, and names. It shows up as potential extra credit. But you will find that Ninja Turtle canon is important in this class.
Are we talking like live action too?
I probably wouldn't ask. Are you talking about the movies?
Yeah.
I probably wouldn't ask depth of the movies because those outside the first one. The first movie was actually pretty solid, but outside of that, you're getting pretty sketchy. But we'll get into more detail with this as the class goes on, but I think I have him on here. See this guy down here? This is one of our stickers. We have a hackathon every semester in the department. So all of you will be participating in our hackathon once we have the dates. So we do about an 8 to 12 hour programming competition thing. We'll pair you up with some juniors and seniors and you do a project for 8 to 12 hours. Now, when you're beginning programmers, you're maybe not going to be able to contribute that much, but you'll learn a lot from it. Well, this is our mascot for our hackathons. His name's Mr. Gonzalez. He's an elf on the shelf that travels the world with my wife and I. He's actually a stuffed elf on the shelf, and he actually travels the world with us. He's been to every continent, including Antarctica. He was on a cruise in Antarctica. He's married to another elf. The wedding was on a cruise ship. I mean, this is stuff that, I've shared with the psychiatrist. So it's but in any case, the problems are real. Okay, but he has his own fish tank at home. He calls it his Oski tank because he has some Oscars in there, but he has all sorts of fish that are not supposed to go together in his tank. And he has what started off as a Star Wars themed tank, but he also has Ninja Turtle things in there. He had Bebop and Rocksteady. Bebop died. He was eaten by one of the Oscars. Oh. He was eaten by Vader, and then Rey ripped Vader's eye out. Vader died, Rey died. We don't talk about how Rey died. Eye for an eye, so to speak. Yeah, so that just gives you the highlight reel. We'll add to that. Those things can also be extra credit on the exams. So pay attention. All right. I don't even know how I got, oh, Ninja Turtle shirt. Be prepared. That happens often. All right. So I was talking about switching languages often, right? So in this first class, we use C++, which is a fairly old language. For most of the first class, up until the first 8 weeks, we'll be using really base C, the C programming language for procedural programming. And we'll talk about what this means. I'm going to have some slides like there are 3 kinds of programming languages. There are 2 kinds of programming languages to really compartmentalize picking the right language for the right job. That for the job you're trying to solve, and because each language kind of lends itself to a certain thing. But I purposely pick an old language like C++ in here because it does not do very much extra for you. All right. One of the biggest, most important skills you're going to learn as a beginning programmer is debugging, fixing your errors in your code. Because even the simplest program you're going to write, you're going to then find you have 500 errors. It was 6 lines long and you have 500 errors. Okay? And that's going to be frustrating, right? Okay. And then you're going to say, yeah, then you're going to say, hey, well, do we have a chair? We got to find a chair for him. All right. Right across the hall is my office. Here, we're going to pause. Let me grab one chair. Everybody hold it up. Yes. There it is. Everybody got a little extra room? And I think you're going to be out of luck there. Maybe just plop down the back. We're going to be moving into a better classroom. This is a very temporary situation. No, he's our program coordinator. Doesn't need another chair. All right. I might even be able to get some of this fixed by Thursday's class, but we'll burn that bridge when we get to it. So anyways, I was saying that C++ I use because it's a language that does not do very much stuff for you. And one of the skills that you really need to get good at, probably the skill you're going to have to get good at first, is debugging. Because most of you are going to write code, you're going to think you copied exactly what I wrote here in class. It's like, oh, I wrote exactly what you wrote. But mine had 0 errors, yours had 500. I promise you, it wasn't exactly what I wrote. You're missing a semicolon here or a period there. You capitalize something that should have been lowercase, or you lowercase something that should have been capitalized. Things like that, okay? Programming languages are case sensitive. All right, so you need to spell things right. You need to, we'll talk about this in more detail, but you need to finish statements with the right symbols, that kind of stuff. It never is the case that something's wrong with your compiler and your code worked. And it's lying to you, and that's why you have 500 errors. Okay, it's always something you wrote. I purposely use a language like C++ because it does not hide any of that stuff from you. All right, it'll be death by 1,000 cuts. Is the punchline. You'll thank me later. And like I said, we go into a lot of detail in how these languages are built. My background is language theory, so I write programming languages. And I promise you, understanding how languages are put together is what will make you a top-tier software engineer. Okay? Having that understanding is important. We're going to have a former student who just graduated this last year come in. He was in your shoes 4 years ago, never programmed before he came to school. He started off in IT. I converted him to computer for software engineering because that's what you should do if you want to get paid. Now he's working as a software engineer, and he currently has the number 6 ranked mobile app on the Apple App Store. He's pulling in about $600,000 a month writing code that he learned how to write in our coding classes here. And this is real. So programming that skill set, it's kind of like being a ninja, right? You got this skill set that a lot of other people do not have. But having that underlying infrastructure, understanding how these languages are built, understanding how the computers actually work under the hood, allows you to solve that last, I kind of always references like that last 20% of problems that somebody who's just kind of learned programming by trial and error will never be able to solve. Okay? C++ being such an old language does not hide any of the details from you. So you will need to be exposed to those details, which will then, the next language we'll use is Java. Java is a much newer language, came out in the late 90s, okay? And you'll see that Java is basically the same as C++. It's based on C++. But there's a whole lot of kind of quality of life improvements that Java put in there. You know, like if in C++ you always had to write this one line this way, a very specific way, why make me type that when you could just do it for me? Java does some of that for you. Java hides some of these details that are important details that if you learn Java first, you would never know they were actually there. Make some sense? So trust me, you're going to hate me initially when C++ scares the crap out of you. But then your future languages will all seem easy because of the amount of convenience they give you. Okay, it's kind of like driving. I mean, you can only go back so far with the age group, but how many of you drive a stick shift car? Have driven a stick shift car? All right. Okay, right. Now we have automatic transmission, right? Okay, when I was in high school, stick shift was cool, right? But you can't drive stick and drink your coffee at the same time. So safely. Okay. Automatic transmission, when you just put it in drive and go, is a convenience, right? It's not doing anything that you weren't doing automatically or manually with stick shift, but it's doing it for you. Probably more efficient than you ever did it, unless you're a professional race car driver where the precision of shifting gears is like super important to like paying your bills. But when you're going to like Taco Bell, you know, the timing of going from second to third gear is a little bit less important. You're probably getting pretty decent gas mileage relying on the automatic transmission rather than you grinding the clutch and stuff. All right. So that's a convenience. You go back even further. Years and years and years ago with the older cars, you used to just turn your car on. You had to get out of it and like crank the engine on the front, kind of like if you ever had one of those lawnmowers, you have to pull the ripcord. You know, they still exist today, right? You know, but now a lot of them have that push button, whatever. But, you know, you used to have to do that with your car. When I first started driving, I didn't have to do that. But when you got in, you had to push the gas pedal down a couple times to put some fuel into the carburetor so it can ignite, right? It's kind of similar if you've been on a boat that has the little ball thing. You squeeze a couple times to get the fuel going, okay? Because it doesn't have fuel injection. Modern cars have fuel injection. You get in and you turn a key, or now you just push a button, right? There's a lot of cars. You push a button, it turns on, okay, and you go. It has a starter in it, so you don't have to pull on some ripcord. It has this little thing that's using battery power, and it rips the engine and spins it up. So we have all these conveniences today with even just a car like we just described that, yes, we appreciate, but you appreciate it a lot more if you came from an older time when you used to have to do it differently. Make sense? All right, so coding is kind of the same thing. We're going to start you off with that stick shift programming language, maybe even a little worse than that. And then we're going to move you into an automatic transmission. But when all is said and done, by the time you're a senior, you're going to be looking at nearly self-driving cars. Okay, where you do things the right way, 3/4 of the code gets written for you. All right, makes some sense? but you're only going to appreciate that if you saw what it's doing for you under the hood. That's why we use a language like C++. Okay. So what's a programming language? Let's kind of hit with the basics here. How many, somebody give me a rough definition of what you think a programming language is. I already gave you some context for this. Go ahead. Okay, yeah. It's a language for telling a computer what to do. Way to talk to a computer, just like English is a way to talk to a human being, just like Spanish is a way to talk to a human being. Programming language is a protocol for speaking to a computer. Protocol, language, same word, just pronounced differently. All right. So sometimes you'll hear somebody say something about, oh, we're using a certain protocol with technology. It's the language that two computer programs are speaking with each other. All right. So programming language, it's how do you talk to a computer? So how do humans solve problems? Since a programming language is built for allowing a human being to tell a computer what to do, there needs to be some kind of translation that happens, right? Okay, because especially since we're dealing with computers, I mean, human beings we're kind of jerks. We're not going to meet this computer halfway. We want the computer to come 99.9% of the way across the street to us. And then maybe we'll do that last 0.1 that's the hard part of programming, right? So we first need to think about how do human beings solve problems? And we kind of abstract this to kind of fit my model here. But, you know, let's think about some problem that all of you solve on every day. How many of you walk to class today? Most of you, right? All right. Any of you bump into any other people while you're walking to class? Bump into any walls? Today in front of you? Well, so you was just playing defense. So you were able to. Now, while you were walking to class, how many of you were staring at a cell phone? How hard is walking? Can you give me, if you had to give somebody detailed instructions on how to walk, could you do it? What's all happening when you walk? All these zillions of muscles are firing in certain orders, and you're kind of catching your balance constantly. You're like falling and catching your balance and falling and catching your balance, and you're kind of creating this swaying movement to kind of keep going forward. So there's all these little tiny tweaks that are happening. That as a really smart human being, when you were a baby, you figured out, right? You fell over a zillion times, but you kind of figured out how to get locomotion going. But you cannot explain in detail how you do it. You just do it, right? That's actually kind of the scariness with today's artificial intelligence stuff. How many of you have heard of ChatGPT? All right, so ChatGPT is a deep learning neural network. And sometimes we call these things black boxes. My first experience with a neural network, today we have programming tools that will write neural networks for you. But my first experience with a neural network, I was in a artificial intelligence class a few minutes ago, and we had to write our own neural network. And then we took that neural network and we trained it. You know, this was our first way of learning machine learning. This is kind of what our modern day AI stuff is based on. Things that you would call AI, even though there's like 20 or 30 different approaches to AI. So what we did is, you remember in second grade-ish, you had the multiplication flashcards. Remember, you had the ones table, the twos table, and your mom would test you with it, and that stuff. So what we did is we created this neural network, and you have a couple different variables you can tweak there, like how many input nodes, how many hidden nodes, blah blah blah. It uses this algorithm called back propagation. Doesn't matter, mathy stuff. Okay, but what we did is we trained that neural network on the 1 through 5's multiplication table. And when we first had the neural network sitting there in its initial state, I mean, it was just random numbers that were inside of there. Then we'd feed it 1 times 1, and it would kind of feed through this network and spit out an answer, complete guess, not even a guess, just following a bunch of multiplication stuff to give you an answer. Chances are the answer was going to be wrong, right? So when it got the answer wrong, what do? Supervised learning. Slap it on the wrist, right? Hard. And then you go and you make little tweaks so that hopefully the next time it sees that input, it gets a little bit closer. And we feed it 1 times 2. Probably gets it wrong. We do that millions and millions and millions of times, tweaking it just a little bit each time, but only when it gets it wrong. And after millions and millions of times of feeding it that information, again, this isn't a computer program, so maybe it took 20 minutes to train it, something like that. You had this kind of perfectly balanced blob, if you will, that could answer correctly all or at least most of the 1 through 5's multiplication table. Make sense? Just by trial and error, right? It didn't learn how to do math. We just kept slapping it around until it finally, and tweaking it until it finally was able to was perfectly balanced to get the answer right. And then we fed it the 6 through 10's table, data it had never seen before, and it got them all right. So we trained this thing on the pattern of multiplication. We would call that a black box because that's not built with logic. Nobody wrote a computer program, even though you could write a computer program for multiplication. That's not a hard problem to solve. That's why you start with that for kind of your neural network examples. But there's no logic inside of that. It's just like this perfectly balanced little math ball that you feed stuff to, and it pings around in there until it spits out the right answer. But after we trained it in the 1 through 5's table, it got the 6 through 10's table all right. And it was data it had never seen before. Isn't that fascinating? We call that a black box because we put input in, we get an output, but we don't know what's happening in the middle. That's kind of like our brain. So even though we can sort of kind of give people a rough guesstimate of how you walk, or pick something less complex, because obviously walking is something we're so good at, we're just texting on our phone and bobbing and weaving in and out of people, so it doesn't even take our full attention anymore, right? We've gotten so good at it. But take almost anything, like making a peanut butter and jelly. The level of detail that we are used to putting out there isn't going to be enough to explain to a computer how to do it. That makes sense? As a human being, we suck at articulating how we solve problems because we're so good at doing it. Does that make sense? That's why coding is hard. Because when you learn to program, you have to get better at articulating how you solve problems. The good news is the problems that we rely on computers to solve are trivial compared to the problems that you solve as a human being. Walking is incredibly complex, billions of times more complex than pick your favorite, most complex video game. Call of Duty, whatever, massive explosions. Writing that game is trivial compared to walking. Does that make sense? So as programmers, we're not asked to tell a computer how to walk. In fact, we couldn't do it. That's why neural networks are kind of getting scary, because all we have to do is try to get the robot to fall over enough times and catch itself, and all of a sudden it figures out how to walk. What happens when it figures out how to do other things? Just go and watch the Terminator movies and you're covered, right? So, but you kind of get the problem here. We cannot articulate how we solve problems, yet we need to articulate in detail to the computer if we're going to tell it how to solve a problem. So right off the bat, we're going to be limited on how complex the problems are that we could program a computer to do. Now, over the years, the complexity of those problems has increased because the power of our computers has increased. But even as much as the complexity of the problems we ask our computers to solve today has increased, it's still nowhere near some of the most trivial problems that a human being does on a daily basis. Make sense? So understand kind of what we're learning to do. Again, people think coding is hard. You're actually telling a computer how to do very simple things relative to what all of you passively do on a daily basis. I've seen students walk into class who have not woken up yet. I mean, they are meandering down the hall. I still hear them snoring. They are walking in their sleep on their way to class. They get to the right room. They're texting while they're sleeping, doing it just fine. No problem. How do you do that? I fall down and get out of bed sometimes. Yeah, you'll get there. Okay. I used all my ninja skills in my earlier days when I was training under Splinter, Master Splinter, of course. Ninja Turtle reference on the exams. All right. So, how do human beings solve problems? I like to think that we use our memory. We ask questions. And we use repetition. Let's take these one at a time. Think about the problems you solve on a daily basis. What if I took your memory away from you? You know, you see it in the movies, and they make light of it, but some of you maybe have had family members who've had, you know, memory issues, whether it's Alzheimer's or other kinds of dementia and stuff. I mean, it's sad. Yeah, short-term memory loss. If you ever saw the Happy Gilmore movie, guy kept losing his, he kept introducing himself, hey, I'm Tom, every 5 seconds when he was meeting you for the first time. We rely on our memory so much, yet we don't even think about it, right? If I ask you what your name is, everybody in here knows what their name is, right? How did you figure that out? Where's that stored? Somewhere up here-ish, right? You kind of, this is your hard drive, right? Somewhere up here, I've stored my name is Mike. Okay, when somebody asks me what my name is, I am involuntarily doing some kind of internal lookup to go and find that variable called my name and looking across and saying, it's Mike. And then I'm spitting that out verbally to them to tell them what my name is. I don't realize I'm doing that lookup. I don't just say like, hold on, let me compute. I don't do this weird thing, but sometimes we do, right? When you get something on the tip of your tongue, somebody asks you a question, you can't come up with that actor's name or something like that. And you think you're searching the data banks, right? Then I always go through the alphabet, right? You start counting through walking through the alphabet. Hopefully, like when you hit a letter, it'll be the first letter of their name and it'll just pop in, right? So we have our little tricks, but somewhere in there, we have this ability to look stuff up in our memory, even though we don't realize how we're doing it. We all believe we are doing it, right? Okay, so if we took that away from us, we couldn't solve almost any problem, right? Memory is important. Okay, what about asking questions? Do we ask a lot of questions? We ask a zillion questions every day. Most of the time, we're so good at asking questions. Well, we're so used to asking questions, we don't even know we're asking them. As you were walking down the hall today to class, as you're bobbing and weaving out of people, do you think you were probably subconsciously saying, am I going to hit somebody? I'm going to hit somebody. Am I going to fall down? Am I going to fall down? Do I need to bob left? Do I need to bob right? Where's that wall? You're asking all these questions about the environment that's around you, and then making little tiny course changes or weight shifts and things like that as a response to those questions. Do we all believe that that's happening? Right? But none of us recognize that that's happening while we're going down the hall. We've learned to block that out, right? All those questions we ask, but we know what's happening. Okay, we use a lot of repetition too. Once we have human beings like patterns. So once we get something, so like even the idea of walking is the same pattern over and over and over again. We just keep repeating the ninja move, right? Over and over again. So I like to abstract how human beings solve problems into these three things. 100% of programming languages, I'm just going to steal this slide. I'm going to call this the mapping. And I'm just saying 100% of programming languages have facilities for these three things. That means if it doesn't have facilities for these things, it's not a programming language. So memory. Programming languages, we have facilities for memory. Typically, we call them variables. Okay. So variables are name value pairs where we associate a name with a value. So like in my head, I might have a variable called my name and its value is Mike. Make sense? Asking questions. Programming languages. This is usually called a conditional. Most languages, it's an if statement. Why? Because it's an if statement in the C programming language, and most of our modern languages come from C. Okay. Repetition, loops, and I'm going to say functions / procedures. We'll talk about those in more details. Every single programming language has facilities for these three things. If it's missing any of them, it's not a programming language. So an example I might use is a lot of times I'll ask when I meet with a group of people, I'll say, you know, how many of you have ever programmed before, like I did in this group? And then I might go a little bit deeper. We were already behind on time because I was bringing chairs in, so I didn't ask this part, but I might ask, oh, what languages did you have? And you get some language like Python is pretty common, Java, okay, but then somebody might say HTML. How many of you have ever done something with HTML or CSS? Some point, maybe something. Is that a programming language? Not a programming language. Why? No memory, no if statements, no loops. That doesn't mean it's useless. It's just not a programming language. It's what's called a data representation language. Okay, we'll talk about those a little bit. They're useful. They're extremely useful. Programming languages utilize data representation languages all the time. But those things are not programming languages because they don't have these three things. Make sense? So let's say, this goes back to what I said earlier, that programming is the skill set, the language doesn't matter. Let's say that you're already a, accomplished computer programmer, at least intermediate level. Got a, 1 or 2 coding classes under your belt, you feel like you're, okay. If I show you a brand new programming language that you've never seen before, but I show you how do you create variables? How do you write if statements? How do you create loops and functions? All of a sudden, you can solve a pretty big classification of problems right off the bat in that language, just by learning how to do those three things. Because almost all of our problems we solve with programming languages are simple things. All hard programs are made up of a bunch of easy parts. If you went and looked at the source code for Microsoft Windows, you would see a whole bunch of if statements, a whole bunch of loops, a whole bunch of variables. A majority of that code is not doing difficult stuff. It's just a lot of code. Make sense? Same thing. If you went and looked at the code for, pick your favorite video game, Call of Duty. Same thing's true. In fact, you probably couldn't even get down to the code. Half of it, we use game engines for implementing it. So I mentioned earlier that we switch languages pretty often. So what you'll do is most of this class you'll be in C++ to get those the fundamental skills under your belt. We start next course off with Java. Around week 8, we switch to Unity game engine. So Ninja Turtle perked up there. So we switched to Unity game engine. If any of you are gamers, you've probably seen video games pop up where it either says Unity at the beginning or Unreal Engine. Those are competitors, same tool. All right. So we're going to be using an industry standard tool for writing video games. It's based on C# programming, which is identical to Java. C# only exists because Microsoft lost a lawsuit. We'll talk about that when we get to that point. Okay. But Unity uses C# as its scripting language, as its programming language. And then it has this nice set of tools for you to drag a 3D model onto the screen and hook different things to it that lets the game engine, apply physics. So you don't have to write the code to make gravity work, or make a boulder flying into a guy, make him act like a boulder hit a guy, right? Because that's a lot of mathy stuff that video games, it's a whole lot about collisions and that kind of stuff. So game engines build all that stuff into it. So all you do is hit a couple of check boxes and all of a sudden, dude has gravity that attaches to him. Do you think, how many of you have ever played the original Super Mario Brothers? Okay. The very beginning, very first level, what do you see? You see Mario, he's a little bit above the ground. He drops down. Mega Man, it's even more. How many played Mega Man? Half a person, 1.5 people. Mega Man, he's higher up in the air. He falls into the scene, right? Because what's happening? He's colliding with the floor. That's how they put him on the floor. Because if you start your character sitting on the floor, if you're 1 pixel off, he might fall through the floor because you may have bypassed the collision. So what early game programmers did, well, even modern game programmers, they just start the character a little bit above the floor and then let gravity make him drop down and he lands on the floor. Now he doesn't have to meticulously place him at the pixel perfect level where he's basically on the floor. So when you watch some video games, try to pay attention to that, especially in those 2D platformer games, that you'll almost always see the character start off just above the ground or higher, and then they do a little animation to make them look like it's on purpose. All right. So game engines do that stuff for you. So you're going to be learning about Unity Game Engine, but really what we're doing is we've just switched the programming language up for you on you to now switch from Java to C#. It's almost like giving dog medicine by hiding it in their food, right? So we're going to keep switching languages on you. At some point, you're going to see Python. You're going to see, .NET architecture outside of Unity. You'll be coding in C# with .NET, Microsoft Visual Studio. When you take the language theory class, you'll be using a language called Scheme, which is based on an old language called Lisp, which is an old artificial intelligence language. Scheme is a superset of that. So you're going to see a lot of different languages as you come through here, but I promise you, every one of them has facilities for memory, asking questions, and repetition. Make sense? All right. So again, programming is the skill set. The language doesn't matter. And that's our goal when we come out of this course, is that you believe that and you've been beat up pretty badly by errors that you've had to debug in C++. And then we show you a language that does a little bit more for you so that you have still a lot of errors, but fewer errors. So you still get beat up, but then it's a little bit more embarrassing because you should know better, but it's still hard. So eventually you get to things like Unity where all this hard stuff's happening behind the scenes, but all you did is drag a dude onto the screen and it just magically works. All right. So we want to talk about types of programming languages. There are 3 kinds of programming languages. We have machine language, we have low-level languages, we have high-level languages. Let's start off with machine language. What's machine language? What language do computers natively speak? Binary, zeros and ones, right? How many of you would want to sit there with a little 2-button keyboard just tapping out your programs? Yeah, you quit the job 5 minutes in, right? Because how many zeros and ones do you think it takes to write a hello world program? Simplest program. Millions. A lot. A lot. And it really is probably millions, because something we don't consider when you write a hello world program is our modern day programs. When we write the syntax for, in C++, it's going to be C out, hello world. That has to communicate with the operating system, which then knows how to put something onto the screen. So when you write hello world on a PC or on a Mac, you write the C++ code, then you compile it, which turns it into machine code, but it's actually machine code that takes into consideration the systems code that's built into your operating system that already knows how to put stuff onto the screen, that knows how to talk to the processor and all these other things. So there's a lot of stuff that you didn't write that are being drugged into your program. Make sense? So if you had to write all that zeros and ones, you'd quit. So imagine back in the early days of computing, programming was not as fun. Make sense? How many of you have ever heard of an author named Malcolm Gladwell? One of his books that he wrote is called Outliers. Fascinating book. And the reason I bring it up in this context, I'll give you a couple examples anyways, but he talks about Bill Gates in there. But so the idea of outliers is the kind of the benefit of timing as it comes to success. So it gives you a bunch of examples. So here's one example. How many of you are hockey fans in here? A couple people? Okay. So roughly 80% of the players in the NHL are from Canada. Is that surprising? Not really surprising. Seems to be farther north you go, the more hockey becomes an everyday thing. Out of those 80% of the NHL players, 80% of them were born in the first 3 months of the year, January, February, or March. Why? Go ahead. That's exactly. Do you already know that? Did you heard that before? Yeah, that's exactly why. You know, some people though, when they first hear that, they'll make this guess like, oh, well, maybe their parents were celebrating the Stanley Cup or something like that. No, it has to do with when you're in junior hockey, junior any sports. There's a pretty big difference in terms of like dexterity, hand-eye coordination between like a 7, 8, 9, 10-year-old. So if you are one of the older kids in your league, you end up getting more ice time, better coaching, you make the traveling team, you have all sorts of advantages that maybe some of the younger kids didn't get. That doesn't mean the younger kids can't still become professional hockey players, but those older kids have an advantage because of when the age cutoff was for junior hockey. Make sense? Okay, here's another similar one. So we're going to have 5 15-year-old American students. We're going to have 5 15-year-old Chinese students. And we're going to give them 7 numbers to memorize. They have 30 seconds to memorize the 7 numbers. 100% of the Chinese students can do it. Less than 20% of the American students can do it. Why? Now, right now, where's the first place you start thinking? Oh, well, maybe the Chinese students are just better at math. Stuff like that, some of the stereotypes, right? The reality is, it's their language. This is where it comes back to programming language here. The Chinese language is more efficient for representing numbers. The human brain is on about a 2-second loop. So anything that we can fit inside of 2 seconds, we can pretty much remember. The Chinese students can say all 7 numbers in less than 2 seconds in their language. The American students, English is not as efficient. They can't fit it into 2 seconds. It has nothing to do with their abilities with math. Their language is more efficient for representing numbers. Things like that we don't think about. Make some sense? Okay. So in this book, the example related to Bill Gates and related to what we're talking about here with machine language is a huge percentage of our current multi-billionaires all fit into a certain age group. Now we kind of have a new wave coming up now, but a huge percentage of the people from like the Bill Gates age, right? And a lot of them were in technology. Obviously, we had this big tech boom over the last 50 years, right? Bill Gates grew up during a period of time where we were transitioning from people writing programs either in low-level languages, which we'll talk about here in a minute, or using things like punch cards. You know, you would have to basically program by hand. And then you take the stack of cards over to, you know, this place that would process your cards and give you the output of your program. And if you weren't happy with it, if you got an error, you had to go back and repunch the cards and bring it back up. Very inconvenient. Bill Gates went to a high school with some rich boosters. And there was a set of parents who I think the story is they knew they had some kind of relationship with this guy who owned a company that had one of the early programmable computers. Now, at that point in time, people didn't know how to use it. How many of you saw the what is the NASA movie Hidden Figures? All right. So the ladies, they were the ones who went and figured out how to use the computers because none of the managers or anything knew how to use the computers, right? Okay. So it was kind of during that time period where people started getting these programmable computers, but nobody knew how to use them. So he had these nerdy friends, and this guy brought the computer over to the school and said, hey, I want you and your couple of friends, talking to Bill Gates, I want you to go and mess with this computer and tell me how to use it. So they would come and they started writing code that you could test instantaneously. So all of a sudden, the complexity of problems that they could program went from here to here, because you didn't have to go and wait for your punch cards to get processed. All timing, right? You take Bill Gates and you put him in today's world, who knows? Maybe he would have been successful, but he would have been missing advantages that he had because of when he grew up. Kind of make some sense? All right. So machine language, we have zeros and ones. And I think we could all agree, while it might be cool for some kind of parlor trick, and we actually will learn about the zeros and ones in here, but it might be cool for some kind of parlor trick, but in general, we don't want the 2-button keyboard for writing our code. Make sense? So what's a low-level language? Before I get to that, I'm going to add a slide here.
Is there any place I can charge my computer?
Isn't there? I think there's a plug right down there. It's like a metal box, right? Oh, that doesn't have power? Then I don't know. Oh, there's an outlet right up here by me. Well, there's outlets up here.
Outlets up here. Yeah,
So I guess drag your computer somewhere. All right. So what's a CPU? Go ahead. Okay, that's what it stands for, Central Processing Unit. But what is a CPU?
It makes the computer run.
Makes the computer run. Okay, tell me more about
Like
that.
the brain.
Okay, like the brain of a computer. Okay. Tell me any more. How does it actually work?
It has cores. It should be better. And then my PC stuff.
I'm going to probably go into deeper detail here than you ever would have. So
I need it.
no, everybody does.
This helps process information.
Okay, it's people will say it's the brain of the computer, processes information, you know, whatever. So we want to think about, how does it do that? All right, so we're going to kind of pretend like we are the human version of a CPU. All right, so everybody put their hand up. All right, so there's one magic trick we all know how to do, right? Everybody can raise their hand. Now, I have a very special skill that most of you can't do. How many of you can do that? All of you. Oh, I thought I was something special. What about this? Okay, so we have 3 magic tricks. Oh, how many of you can put your arm out like this? Oh my gosh. So if I were to go pick up my coffee cup here, I'm using a collection of a couple of those little things to ultimately grab this coffee cup, right? A CPU is like that. A CPU has a collection of little tiny problems it knows how to solve. Put an arm up, put an arm out, wiggle some fingers, whatever. Imagine the techie version of that kind of stuff. Okay, so like maybe there's 1,000 little tiny mini things that a CPU knows how to do, and any one of those individual things is not all that interesting in and of itself. A lot of them are like, oh, move this piece of information from here to here. Okay. All right. So, but if you put enough of those little magic tricks together in a certain order, all of a sudden you start solving real stuff. Like we just did with the picking up the coffee, very important early morning thing, right? Imagine if I didn't have those, I just had to kind of go in and, okay, so the more magic tricks we have in our CPU, the more things we can accomplish. When you go out and buy a piece of software or buy a video game, a lot of times it has the minimum system requirements, right? And one of those minimum system requirements is the CPU. One of the reasons that's the minimum system requirement, it isn't always about speed. It might be that the people who program that software, they compiled it for a certain hardware architecture, compiled it for a certain processor. And if you have an older processor than that, it might be missing some magic tricks that that software requires. Maybe it doesn't know how to do that move. Make sense? When you buy an Intel processor, each one is a superset of the previous one, right? And what do? And then they trick you. So one of the things we're going to try to do is we're going to try to make it so you don't get taken advantage of at Best Buy. Okay, all of you need to know stuff more than the Best Buy people. Any of you work at Best Buy? So Genius, well, no, Genius Bar is the Apple people. With the Geek Squad. Geek Squad is Best Buy people. So when Intel releases a new processor, one of the things they'll maybe say is they'll say, you know, up to 75% faster than the previous generation. Heard things like that? What does faster mean in a processor? Is it? What's when you have a processor that's 3.5 gigahertz? What does that mean? What's a hertz? Okay. We could probably, even though you can't really compare it across different architectures, you can roughly think of a hertz as a number, as one instruction per second. So 3.5 gigahertz is figure 3.5 billion instructions per second times the number of cores in a processor. So processors might have 8 cores in it today, right? At least 4 cores in it today. Each of those cores is its own processor, and each one runs at whatever that gigahertz rating is. So that means each one can do 3.5 billion instructions per second. So you got 14 billion instructions per second, but only if you can give it enough subdivided instructions for it to actually do. That's kind of its maximum speed. All right, just like a sports car might be able to go 200 miles an hour, okay, but probably not in a school zone. Right? So if you're limited on kind of when you can really open it up, yeah, you might be running into some issues. Okay? But if we just think about Intel, when they say, oh, the processor is up to 75% faster than the previous generation, usually when you really dig into it, they've optimized one of those little magic tricks. Or what they've done is they've built in a brand new magic trick that is kind of a combo move of maybe 2 or 3 of the previous magic tricks. And if you use that combo move instead of 3 individual tricks from before, it's 75% faster. Now they can claim that the processor is up to 75% faster. When for 99% of the things you do, probably 100% of the things you do, it won't be any faster. It'll just be twice as expensive. Go ahead.
Can I use the bathroom?
We're actually done. So feel free to start wrapping up, start packing up. I'm just going to make a couple of comments here. So I'll just say start here. So we'll actually review a little bit of this.
Do you have a PC?
Yeah, I actually have a PC on here. There's Windows right there. I have a desktop. Yeah, I do a lot of virtual reality stuff.
Like Intel or AMD though?
I am running a 128 core AMD with a 4090 Ti.
I just want the 5900
And I see you're running a AMD.
Yep.
Yeah. So this is this Mac. So
has AMD.
no, well actually it does, but you don't run this for games.
Yeah.
Yeah. But this has 96 gigs of RAM. This is an M2 Max processor.
Why are Macs still like?
Is it all just because of this like work and stuff?
Well, Max, actually, the new hardware they have is pretty sick. We talk about the CPUs. I run it with so much RAM and stuff because because I run multiple operating systems on a single machine.
That makes sense.
I need all the RAM, I need all the cores.
I was like, 96.
Yeah. Otherwise, I mean, you're never going to use 96 gigs of RAM on a single.
I have 32 gigabytes. And
You're
it's
never
not-
gonna use that.
no,
Yeah.
A lot. Thank you. Have a good one.
Yep. And I'll get the Blackboard course opened up today and get the videos up and stuff. Just give me a little bit of time to get that working.
But also it's private.
What is?
Oh,
Yeah. That's why I said I'll get it open up. They gave me access to it like at 2 in the morning.
Open up at 2 in the morning to open it up.
No, that's when I got my notification on my email that, like, you've now been associated with class X, Y, and Z.
You read the outlier book?
And well, that was the one I was referencing as Outliers.
Yeah.
He has another book called Blink.
I read both of them. Funny story.
Well, you didn't raise your hand when I said how many of you have heard of this.
Because you said Malcolm